Hello, friends. Welcome to my embedded school. Have you ever noticed the colorful little components on circuit boards? Moreover, it has the ability to regulate the current flow across many circuit boards. It is known as a resistor, and it is among the most significant and fundamental components of electronics. We shall discover the definition of a resistor, its operation, and its various kinds and applications in this video. So, let's begin. We will first understand what a resistor is. A resistor is a passive and linear electrical component that has two terminals and provides electrical resistance to the current that passes through it. Resistance is property of how much a resistor opposes or reduces the flow of current. The higher the resistance, the lower current. The lower the resistance, the higher current. The Greek letter omega represents the ohm, which is the unit of resistance and is named after German physicist George Simon Ohm. To understand resistor, we can assume resistor is a pipe that restricts the flow of water. The narrower the pipe, the higher the resistance. The wider the pipe, the lower the resistance. If more current passing through resistor, the more generates heat. Why do resistors generate heat? While an electric current passes through resistors, they heat up. Heat is produced when resistors do not consume all of the extra energy. This may occur when a resistor's power rating is exceeded, indicating that the resistor is unable to withstand the supplied current. Another factor that can affect the temperature of a resistor is self-heating, which is when the resistor's resistance changes due to its own temperature. As a result, selecting the appropriate resistor for the circuit is crucial. To measure the resistance of a resistor by an instrument called an ohmmeter or a multimeter. To measure resistance, first set the ohm function and connect the two probes of the instrument to the two terminals of the resistor and read the value on the display. Another way to find out the resistance of a resistor is to look at its color codes. Resistors have colored bands on their bodies that represent their resistance values and tolerances. Each color corresponds to a number from 0 to 9, and also to a multiplier and a tolerance percentage. For example, a resistor with 4 bands of yellow, violet, red, and gold. The first 2 bands indicate the first 2 digits, the third indicates the multiplier, and the fourth indicates the tolerance of resistors. If a resistor has 5 bands, the first 3 are digits, the fourth is a multiplier, and the fifth is a tolerance band. The first band is yellow, which is 4, and the second band is violet, which is 7. These two numbers combine, which is 47. The third band is multiplier, which is red. Which means 47 times 100 is 4,700 ohms. The fourth band is gold, which means a resistance value of 4.7 kiloohm, 4,700 ohms, with a tolerance of plus or minus 5%. There are many types of resistors, depending on their design, function, and application. Fixed resistors, resistors that have a fixed or constant resistance value that does not change with temperature, voltage, or time. Variable resistors, resistors that have an adjustable resistance value that can be changed by using a knob, dial, or screw. Thermistors, resistors that change their resistance with temperature. They are used for temperature sensing and control. Light-dependent resistors LDRs, resistors that change their resistance with light intensity. They are used for light detection and switching. Potentiometers, variable resistors that can divide a voltage into 2 parts. They are used for volume control, brightness adjustment, and calibration. Resistors are widely used in many applications, such as current limiting, voltage dividing, voltage dropping, biasing, and filtering. We learned what a resistor is, how it functions, and its various types and applications in this video. Essential parts of electronics, resistors regulate the flow of electricity in a variety of ways. They are involved in many fields and devices that we use. For more videos on electronics and technology, please like, share, and subscribe to our channel if you liked this one. I appreciate you viewing.